start the lesson. There's 3 questions there that will probably take a little bit of time. So hopefully you'll finish them before recess, and then when you come back we'll look at 7I.2. And that'll take us to the end of our textbook work on Chapter 7 on complex numbers. So when you come back we might have a bit of a discussion about what the plan is for next week and leading up to the test on complex numbers. So here we have, find the modulus of z given this statement is true. So what we're going to use here is some properties of modulus, okay? We have the modulus of z squared is equal to z times the conjugate of z. Okay, so we're going to use this property here. So what we're going to start off with, we've got both sides of the equation. We can do anything we want as long as we do it to both sides. We're going to square both sides. Okay, and so the square will distribute onto the 4 and onto the z plus 1 modulus. All right, then we're using this property of modulus here, that the modulus of z squared is equal to z times the conjugate of z. So that means we can express this as z plus 16 times the conjugate of z plus 16. Okay, we'll do the same over this side. Then we're going to use another property of modulus. Okay, we have z plus w is modulus of z plus modulus of w. Look at this, we're saying the conjugate of the sum of 2 numbers. So what that's going to become here, we're going to have z plus 16 times the conjugate of z plus 16. Why? Because when we're talking about a conjugate, okay, if we have the number 16, it's plus like 0i, isn't it? There's no imaginary component. And so if we find the conjugate of this number, it's going to be 16 take 0i. It hasn't changed its value in any way. So the conjugate of 16 is just 16. So the conjugate of z plus 16 becomes the conjugate of z plus 16. So that's a legitimate operation. We'll do the same over this side. Okay, and then we're going to do some FOIL. Alright, so technically we can't do perfect square expansion because they're not the same term, it's not a perfect square, but we can do some FOIL here. So we've got z times z conjugate plus 16z plus 16z conjugate plus 16 squared. 16 squared.
256.
And over the other side, I'll leave the 16 out front for now, but we'll have z conjugate. Okay, the 16 can distribute as well, so I might do that in this one step, just in the interest of space. Plus. Okay, and then let's look at what we can do to both sides of the equation. Okay, we can do anything we want as long as we do it to both sides. I'm going to take 16z from both sides, okay, so that can cancel. We'll cancel here, and I'm going to take 16z conjugate from both sides as well. So that will cancel, and that will cancel. So we're doing the same operation on both sides, we're getting rid of it. And then we're going to just sort of collect like terms. I'm going to move this one over. So I'm going to have 15z conjugate over here. And over this side, if we move 16 over here, we'll have 240. on 15.
16.
Yeah. 5 and then plus the 1. Now, z conjugate, all right, what was our first rule up here? Z conjugate is the modulus of z squared. So we can convert that back, square root both sides, we have the modulus of z squared. So there's 2 or 3 questions in the textbook that follow a procedure pretty similar to this, and that's what we're going to dedicate the first half of the lesson to. Any questions about any operations there? Splendid, let's get into it.